Water has a density of about 1 gram per cubic centimeter. If a pool in the shape of a perfect cylinder has a radius of 2 meters and a depth of 3 meters, what is the mass of water, assuming it is completely full of water, with a density that is exactly 1 gram per cubic centimeter? It turns out, originally, the definition of the gram was such that at 4 degrees Celsius, there'd be exactly 1 gram of water in a cubic centimeter. For this problem, we're just going to say, since we're told that that's exactly true, we're just going to say rho is equal to 1 gram per centimeter cubed. Maybe I can make that a 1.0 just to, I don't know, I feel like that looks better. So the question we're being asked here is for the total mass. So I'm going to write, to help maybe my thinking with this, say we're looking for M. Since density is defined to be mass per volume, this suggests that mass should be equal to density times volume. So the thing I think I should turn to now is solving for the volume of this pool. So we were talking about a cylinder-shaped pool. Maybe I can roughly draw a picture of this. It has a depth of 3 meters, a radius of 2 meters, so that really means a full width of 4 meters. And I'm saying that as if I'm going to take that into account to draw it with perfect accuracy. But as we know, my drawing skills are nowhere near that level. So anyways, hopefully this is good enough. And so in this picture, I would say, okay, if that's the depth of the pool, and I still use h, even though h kind of sounds like height, but this is for a vertical height of this object, which really is the depth of the pool, and that's equal to 3 meters. And then we have that radius is here, right? So that's a radius r, which is equal to 2 meters. I don't think I got space for the 2.0 there if I were to follow the style I'm doing with the other numbers. The volume of a cylinder is equal to the area of an end cap. So that would be pi r squared times h. So with the numbers that I have here in my picture, I can make that 2 meters squared times 3 meters. Did I forget to say the pi? The pi is there too. So pi times 2 meters squared times 3 meters. Go to my calculator. And my calculator says for that it is 37.699, etc. Let's see. This is an intermediate result, so maybe I shouldn't round too much, although I think to get to the final result it's only going to be factors of 10, but I'll still follow my usual rule. And so this is what I got for that volume, rounded off at some arbitrarily precise point. So as we said, the mass is going to be equal to volume times density, which was 1.0 gram per centimeter cubed. Recognize, though, I'm going to use this space over here because I might want some more space at the bottom and get crowded. So I want to convert grams per centimeter cubed into base units. So I'd want to multiply by a kilogram per 1,000 grams. And then let me also multiply on the next line here because I'm running out of space to the right there. For every, I'm going to multiply by 100 centimeter divided by a meter. However, it's centimeter cubed, so I'd actually want to, whoops, my pen slipped there. I'd actually want to cube that. And so that's really divide by 1,000 multiplied by 100 cubed. 100 cubed is really, that's like, 10 to the 2 cubed is really 10 to the 6 divided by 10 to the 3. So this really is just equal to 10 to the 3, which is 1,000 kilograms per meter cubed. And so using the formula up here now as my guide for plugging in, I have that density of 10 to the 3 kilograms per meter cubed multiplied by this volume of 37.699, maybe over specified there, meters cubed. And so we're going to get a result in kilograms, and this would be like 3.7699 if I didn't round, times 10 to the 4, right? Because this is 37 times 10 to the 3, so that's really 10 to the 4. I don't think if we were to ask, like, well, what significant digit should I round to here? The way this problem is presented is a little bit difficult for that. I mean, maybe I could assume that everything is exact, but I'm just going to default say, the minimum maybe is 3 digits. That's kind of my rule of thumb. If you're not sure, just keep at least 3. And so we'll say 3.77. Whoops. I forgot the power of 10. Because we said 3.77 times 10 to the 4 in scientific notation kilograms. And let's see how that works out with the slide. Looks like we got it correct.